All right. Gracie, geometry 5.1, lesson 206, page number 206, something like that. We're going to have a couple of different things here. One of them is called circumcenter. One is called orthocenter. Circumcenter, to do these on any kind of triangle, number one, you have to have a perpendicular bisector. Perpendicular means 90 degrees. Bisector means it cuts a side in half. It cuts a side in half, and at that point, you draw a perpendicular to it. Right here, that is the bisector of this side here, right here, and I go perpendicular. This side over here, I cut it right straight in half and do a perpendicular. Where they meet is the circumcenter, okay? Now, Gracie, you got to listen to me. The best way to do this, about the only way you're going to get it done, is after you draw your triangle, you have to have some kind of 90-degree thing. This, it could be a track. It could be a piece of cardboard. Something that will allow you to do 90 degrees. You have to get this cut in half pretty exactly, okay? And then you lay your deal down here and you just draw like this. It can go above, below, okay? And you do the same thing here. You go however far it takes. Same thing here. However far it takes, all right? So you have all the perpendicular bisectors. Where they meet is the circumcenter. It will be different for an obtuse triangle. It will be different for a right triangle. You just have to find. Now this one here, yeah, everything's cool on here. You just have to cut the side in half, 90 degrees. Cut the side in half, 90 degrees. Cut the side in half, 90 degrees. That is the circumcenter. Now, if everything worked here according to plan, technically what you're supposed to be able to do on a circumcenter is you put a compass on the center of this thing. Okay, last time I tried this, it didn't quite work. We'll just see what happens here. You go to a vertex. Got to find a marker that'll go into this thing. You hit on a vertex, and if you draw a circle, again, it doesn't quite work because my circle's not perfect. But, you know, that's the theory anyway. If you do it right, it'll be the same distance here, here, and here. Okay? Any circle going around here will touch here, here, and here. This will be a object, triangle circumscribed inside of a circle. If I did it right, which I didn't. Okay? Over here, we're going to do altitudes. Remember, altitude is from a vertex 90 degrees to the opposite side. Okay? So I go from here, I drop down at 90 degrees. That's an altitude of a triangle. Over here, on this side here, I extended the side out 90 degrees to the vertex is right here. Again, I extended the side out 90 degrees to the vertex here. If you have a wildly obtuse triangle like this, all right, to get this vertex, this altitude is right here. But to get this one, I have to extend this side out. Okay, and I'm going to come down right here. There's the altitude. Okay, and I'm extend, let's see. Okay, I got this point. I have this one. I need this one here. So I need the opposite side. So I'm so lost here. I'm going to extend this side down. I'm sorry, there it is. And I'm going to go 90 degrees to it. Right here. And if I did it right, they all are going to meet right here. That would be the orthocenter for that. Okay, sometimes you have to extend the side out. What I'm getting to say is sometimes the orthocenter will be on the outside. Sometimes it'll be on it. If I did a right triangle here, obviously the altitude for this side is right here, and the altitude for this side is right here. And if I do the altitude for this side right here, they meet right there. So the orthocenter could be outside the triangle, on the triangle, or it could be inside the triangle if I had a little acute triangle. Okay, same thing here with the circumcenter. It could be in the triangle, it could be on the triangle, it could be outside of the triangle, depending on the shape of the triangle. You just have to watch what they ask and do what they say. Okay, I like that. Watch what they ask and do what they say. Okay?